Yesterday, I went over a story where there was a review done of an incident that happened because of a ransomware attack, and we had people who lost their lives. For example, there was a 78-year-old woman who could not go to her closest hospital while she was suffering from some kind of medical condition because the hospital had to be shut down as part of a cyberware attack, and she had to go to a farther hospital, which was the just the right amount of critical time she needed to save her own life. She couldn't, and so she was unfortunately 404'd. And as I was reading some related articles that I'll cover in future streams, I came across this. Yet another instance where software can literally lead to people's 404ing. The 1992 London Ambulance Service Computer Aided Dispatch System Failure. So what happened here is that this ambulance service could not function correctly. The London Ambulance Services 1992 Computer Aided Dispatch, so LAS and CAD, software system failure, is one instance of the considerable negative effect that a small error in software can have on a large population of people. A careful examination of the events surrounding the incident, however, suggests that there was more to the issue than just an error in the software. Rather, the overall carelessness with which the application's development was approached from its conception set the stage for such a grand failure. In 1992, the London Ambulance Service provided ambulance service to 6.8 million people living in a 600 square mile area. Of its 318 emergency ambulances, an average of 212 were in service at any given time, in addition to 445 transport ambulances, one helicopter, and a motorcycle response unit. A total of 70 ambulance stations, which employed 2,746 staff members, housed these vehicles. The entire system was managed from a central location at the LAS headquarters in Waterloo. On average, between 2,000 and 2,500 calls were received daily, 60% of which were requests for emergency services. The LAS devoted 55% of its staff and 76% of its budget specifically to emergency response. According to Wikipedia, the LAS remains the largest ambulance service in the world that does not directly charge its patients for its services. This is quite the operation. A lot of people are obviously dependent on this service in order to get critical care that they need in times of emergency. So they have call taking, they have resource identification and mobilization, which is essentially like who needs priority help, who should be sent. They found that having humans handle all the calls led to a slowdown, or what would be considered a slow response rate. So the government imposed stipulation that calls be responded to within 3 minutes, in addition to the obvious deficiencies of the manual dispatch system, led to those in charge of the LAS seek out a computer-based alternative. And so, of course, they started looking at their options to see how can we automate a lot of this dispatching stuff so that people can get critical help that they need faster. Management set big goals. Well, actually, it has to start from here. The LAS looked at adopting an existing system, but found problems with each of the available options. LAS management decided to create a new one and to proceed to gather requirements without receiving input from ambulance crews or dispatchers. And so the problem, as you can see, already begins. This is a typical thing that managers and executives like to do. They like to think that they are capable of inferring the usage of their users simply because they have some high-titled position and they don't care to think about the consequences of their actions. Okay, this isn't new. This has been happening since time immemorial. Management set big goals. Rather than simply assisting dispatchers, this completely computerized system would do nearly everything automatically. The simple sequence of steps performed by a person would be to answer the phone, enter incident data into a computer terminal, and then respond if the system displayed exception messages resulting from no ambulances being available for longer than 11 minutes. The location of calls would be mapped by the software. The system would then use this map data and the location and status details provided by the AVLS, which is the Automatic Vehicle Locating System, to find and dispatch the available ambulance closest to the incident's location. To top it off, this system would be implemented not incrementally, but all at once. What happened? After a whole slew of issues, including a project cancellation and redesign, a software system got developed and was deployed the morning of October 26, 1992. Just a few hours later, however, problems began to arise. The AVLS was unable to keep track of the ambulances and their statuses in the system. It began sending multiple units to some locations and no units to other locations. The efficiency with which it assigned vehicles to call locations was substandard. The system began to generate such a great quantity of exception messages on the dispatcher's terminals that calls got lost. The problem was compounded when people called back additional times because the ambulances they were expecting did not arrive. As more and more incidents were entered into the system, it became increasingly clogged. The next day, the LAS switched back to a part manual system and shut down the computer system completely when it quit working altogether 8 days later. Because of the large area serviced by the LAS, many people were directly affected by the computer system failure. There were as many as 46 deaths that would have been avoided had the requested ambulance arrived on time. One heart attack patient waited 6 hours for an ambulance before her son took her to the hospital. 4 hours after that, the LAS called to see if the ambulance was still needed. Another woman called the LAS every 30 minutes for almost 3 hours before an ambulance arrived. It was too late as her husband had already died. One ambulance crew arrived only to find that the patient had not only died, but his body had been taken away by a mortician. Dare not one soul ever come to me and say, "Good enough, bro." Immediate causes. At the time the system went live, there were 81 known issues with the software, and no load tests had been run. No provisions for a backup system had been made, while the gap of 10 months between the time dispatchers were first trained to use the software and when it was deployed played its role in the disaster. The software had 3 primary flaws that immediately caused the failure. Imperfect data. The software system did not function well when given invalid or incomplete data regarding the positions and statuses of ambulances. This should be one of the most basic things that you should do. Anytime that a programmer is coding something, pretty much it should be a standard operating procedure that you should assume that the data you're being given when you pass it in through a function or whatever is going to be incorrect or incomplete. We should be starting from a point of not trusting the data that you're being given. I realize that there are exceptions to this and that sometimes you don't really need to do that, etc. But I'm talking about a general rule, right? And so this was ignored here when you have people's lives in your hands. Interface issues. The deployed system had a wide variety of quirks in different parts of the user interface. For example, parts of the MDT terminal screens had black spots, thus preventing ambulance operators from getting all information needed. Yeah, literally some black spots on the rendering of the data caused you couldn't even read the data. When ambulance crews attempted to remedy mistakes after pushing incorrect wrong buttons, the system did not accept the fix. Again, the software failed to compensate for the error conditions that occur in normal day-to-day operation. Memory leak. Rust mentioned. The root cause of the main breakdown of the system, however, was a memory leak in a small portion of code. This defect retained memory that held incident information on the file server even after it was no longer needed. As with any memory leak, after enough time, the memory filled up and caused the system to fail. Deeper causes. IEEE member and risk management expert Robert Charette, suggests bad decisions by project managers are probably the single greatest cause of software failure today. While the software controlling the LAS's CAD system had some key flaws, without which the system may not have failed to the extent it did, the events surrounding the failure, the state of the LAS as an organizational entity, and the process with which the LAS approached the development of the CAD played just as large, if not a larger role in the system's failure. And this hasn't changed today. Today, you not only need programmers to be persuaded and encouraged to learn fundamentals and pick up more than the abstractions and frameworks that they rely on, but you also need a cultural change in this industry, which is why I'm trying to do what I do. Managers and executives and companies as a whole also need to get on board with the fact that the last 10 to 20 years has been mired by bad decisions in tech, and it needs to change. And making that change might have some short-term costs, but the long-term benefits are massive. They're underwhelmingly underhyped, I want to say. They're underhyped, the benefits that we'd have, even just from a greedy financial corporatist perspective. So this problem is still in existence today. Getting the LAS CAD system to the point of deployment was challenging and opened the doors for failure to creep in at several points. The original design of the LAS's CAD system was first proposed in 1987. It was modified in 1989, and then, due to gross overspending by about 300%, the project was canceled in 1990. However, the national mandate to reduce emergency response times pushed the LAS to look into a computerized system once again. So they failed the first time, 300% over budget, canceled it, and then they decided, no, we have to keep going. Okay, because the government pressure was still there, right? When the project was reopened, those LAS individuals in charge of it approached it with the primary goal to save as much time and money as possible. While this is a reasonable aim of any project, it held too much weight in the LAS's CAD project. As part of the attempt to save money, the LAS decided to reuse some of the hardware that had already been purchased when working on the failed project, instead of purchasing hardware that was either more up-to-date or more suitable for the new system. Vendor selection. The two people who were primarily in charge of choosing a software vendor for creating the system were a manager expecting to become redundant and a contractor who was a temporary addition to the organization. These individuals' roles and their lack of stake in the project draw into question their ability to select the best company for the job. Further, the selection committee weighed a bid's price as the most important factor in selecting a vendor. All companies that submitted bids greater than $1.5 million were immediately thrown out. This is an unreasonably low price, especially considering the fact that even after $7.5 million have been poured into the previous attempt at a CAD system, the project had failed. I just want to summarize the reasoning. The reasoning here is, hey, the last time we did this, we were 300% over budget. We spent $7.5 million. So you know what we need to do this time? Spend as little money as is absolutely possible. Selection of a developing organization was further constrained by the requirement that the project be completed in 11 months. Once again, any bids not meeting this hard constraint were not considered. Several companies proposed modified deployment schedules in which some functionality would be delivered after the 11-month deadline and the rest a year later. These too were thrown out. The LAS accepted a bid of just under $1 million that was submitted by a conglomeration of companies. The software portion of the system was offered as a throw-in-a-hardware deal for a meager $35,000 and was completed by a company called System Options. The fact that the majority of the cost for this package, which relied heavily on software, went instead toward hardware should have raised a flag that something was askew. In other words, this company said, hey, for $35,000, we'll build the software. The rest of the $1 million goes towards the hardware. Further, System Options was declared the project lead. Though it had developed many smaller software packages, System Options had never worked on such a large project and had absolutely no past experience with real-time safety-critical command and control systems. Its inexperience developing such software led the contractor selection committee to raise concerns over the company's ability to perform the task at hand. However, even though these concerns were further substantiated by an audit of the selection process, the LAS hired the company. The process through which the requirements were gathered and specifications and designs were written had several major flaws. First, it seems that a LAS team, not a software development team, went through this process without attempting to consult ambulance operators, dispatchers, and other key users of the system. A basic understanding of the software requirements process suggests that leaving out key stakeholders is detrimental to the project and will result in an incomplete set of requirements. Further, the requirements document was highly detailed and extremely prescriptive, very much a direct contradiction of the requirements process focus on the what as opposed to the how. Once the companies completing the project were selected, they were required to provide a final system design spec. The LAS incorrectly assumed that if the contractor could do this, they understood the system they had to create. However, there was no sign-off on this design spec and it was updated after development began. Flawed software process. Several other parts of the software process played a large role in the eventual failure of the deployed product. No quality assurance was performed, configuration management was absent, agreed-upon changes were not tracked, and test plans were not written, just to name a few. At one point in the CAD system's development, the LAS considered hiring one of the other bidders to perform some quality assurance tasks. Because this was seen as the job of the developing organization, this idea was disregarded. Though any developing organization should be able to ensure its product's quality, testing is impossible when getting the project coded in the allotted 11 months is an already unachievable. So then they go on to say how, all of these factors played into it. What this story underscores is that whether you are a programmer, manager, executive in the tech industry, taking a little bit more time and a little bit more care about the way that you approach your products, your code, the fundamental underpinnings of the things you create, the impact that this could possibly have on other people's lives. And yes, it's true that this is an ambulance service, so I understand that there is a direct impact. But imagine that you are, maybe you're an e-commerce company and you sell like cat paraphernalia to, say, just people who own cats, right? And you gather a bunch of payment information from these people who go through your store, and because you didn't take some time to just be really careful about the security of all of this payment information that you're grabbing, it gets leaked. And as a result, someone loses their life savings, or they become, what would you say? They become a victim of something like identity theft, right? There are more than one ways to ruin someone's life beyond just you're an ambulance service and people, as a result, lose their life.